Okay, so we're going to cover just a couple of things here. We're going to talk about what ensemble mode is. We're going to talk about I/O redirection in Rayleigh, and then we're going to do a quick exercise with ensemble mode. Okay. What you want to do though, copy with this little dash little r module 3 to module 4. Okay. Don't. Well, you probably should go in and verify that each run works. So let's just do that together, right? So. First, I need to change that. Okay. So cp-r, module 3, module 4. And I'll go into module 4/boost, and I'll run Rayleigh. And just make sure. We just want to make sure they all run independently. Okay, so that one's good. I'll go to Anelastic ND. And I'll run Rayleigh. If anyone has a problem here, let me know, because it's possible when we copied, your virtual machine may not treat the soft link the same way. Mine will just copy. Okay, and then I'll go to Anelastic. Okay, so those all work. Alright, so what is ensemble mode? It's very simple. The idea is that you can run multiple simulations under the umbrella of one executable. And there's a few reasons for this. One is if you like to do parameter space studies, this can be useful. You set everything up at once, you fire it off into the queue, either as a single chunk or as multiple chunks of the parameter space study. It's useful for organization. I often forget when I'm trying to do a parameter space study, I forget which runs are equilibrated or not. And if you're kind of moving everything through at once, it helps a little bit. The other reason is queuing policies. Sometimes it may be easier to move through the queue if you can bundle two 512 core jobs together as opposed to two individual separate 512 core jobs. Or separately, it might be nice, you might be able to run your simulation on 1024 cores, okay, but it's not that efficient, and if you've got another one to do, you might as well just push them through together at the same time on 512 cores, because you'll always lose a little bit of efficiency as you run on more cores, so you can kind of keep your computing hours this way too. So the mechanics of this are pretty simple. There's a modified call to Rayleigh, so we have that MPI exec /Rayleigh, and all we do is we pass a little flag to it with the number of runs that we want. Okay. Each run will still have its own dedicated directory, just like we made. Basically, we have these 3 runs, and the number of MPI ranks that we call Rayleigh with has to agree with all the MP row times MP calls in those individual input files. And then I have a note here. Okay, so this is still under development. It is absolutely fine to use for stable runs. Okay, but if you're trying to sort out what the resolution needs to be for a given run, when that thing crashes, those processors will just go idle, and the other cases will keep going, and it doesn't have an intelligent kind of message system. So you really want to use this for stuff where you sort of know, this is what I'm doing. I'm ready to just run everything for a diffusion time or whatever time scale you care about. Okay. All right. So here's what you do. So normally when I do these, I have an overarching directory, and that's what this module 4 directory is. So while we have Rayleigh and all the little run directories, that's not where we need it for ensemble mode. So we're going to link it into our module 4 directory. And then once we do that, we're going to make in the module 4 directory a little file called run_list. Okay? And what we're going to do is we're going to add 3 lines to that, which are just the names of our cases. And then we're going to include a blank line at the end. Okay? The blank line doesn't matter for every compiler, but it matters for some. And so just always put it, and you won't have any problems. Okay? So let's do that right now. It's very simple. So I'm here in module 4. I'm going to soft link Rayleigh there. Now I'm going to edit run list. The order you put these things in doesn't matter. They just all need to be there. Okay, and then I have my new line. And then once you've done that, you can go ahead and type this command, where n will probably be 12, since you were running with 4 processors for each run. So I've got Rayleigh here, I've got my run list with a blank space at the end, and then I'll say mpi exec-mp12 /Rayleigh -nruns 3. Okay. And then this is what I get. What you should see is basically the output from all of the runs happening simultaneously. And so that was the first thing I noticed when I got this working. I was like, oh yes, that's obnoxious. Yeah, here's the command. There's a little 3 at the random. So mpi exec-mp12 /Rayleigh-nruns 3. Okay, so that's good. This works, but your log file will get bigger and bigger and bigger as the thing runs, because you've got all these runs writing to the same log file. And some systems don't let you write a log file that's very long. Pleiades is like that. Okay. So what we can do is we can redirect Rayleigh's output to a text file. Okay. And we'll redirect it for each individual run. So if you'll look in your I/O name list, your main inputs, you'll see there's a little I/O controls name list that's empty right now. If we add these 2 flags in there, we can redirect output to a file of our choosing. So we might just call this Rayleigh.out. This will be redirected within the run directory. Okay, so Rayleigh.out will appear in each run directory. And then we have this standard out flush interval. So what happens is there's a little buffer for lines of text in the code, and it just flushes every so often, right? And the idea is you don't want to flush too often because you're writing to disk all the time. So let's just try setting this in all 3 of our input files. And I usually keep it around 1,000. It's like every 1,000 time steps once the code gets going. It's also worth pointing out that the flushes occur like when the time step changes or when the code completes normally. So it will always flush whatever's in the buffer so you have the full log file. So I'll go to each directory, boost, edit the main input file, and I/O controls is down just a little bit. We have the standard out flush interval, set that to 5. No. The only things that really matter, I think maybe these can't be indented. You have to be careful about the start and the end and the beginning of the name list. But no, in here it doesn't seem to care. So what did I say that was called? So std out file, right? Okay, so I did that in boost. So I made that modification to all three inputs, and then I'll run the code again with the same command. And now when I run the code, all I see is this one statement printed. It says multi-run mode enabled. And so the runs are going on. We're just waiting for them to finish. And they're writing to these little Rayleigh.out files within each directory. Okay, so then if we look in these different directories, so if I do like a more on boost / Rayleigh output, or Rayleigh.out, I'll see there is the preamble, runs for 10 iterations, and it finishes. Okay. Same deal if I look at anelastic / Rayleigh.out. I'll see a different preamble telling me it's a dimensional setup, and then a report of everything that happened. Okay, so we'll stop there. This is kind of all the nuts and bolts of actually running the code, controlling the physics, the resolution. Okay, well thank you all very much.